this is Britt Caswell, and this is my next video about factoring. In this video, we are going to discuss a difference of squares. So a difference of squares is when we are describing two things being subtracted. So if you notice, all of my example problems here have a minus sign in them. When we're talking about a square, we're talking about a perfect square. If you refer back to our factoring big picture, we're looking at all the numbers that we had written down on the left. So looking for numbers like 1, 4, 9, 16, 25, 36, etc., etc. So those are the magic numbers that we're going to be looking for when we try to factor these. Now, a difference of squares is really nice in that it always follows the same pattern. So if you have an expression that is some number squared minus some number squared, what you can do is you can break it up into two sets of parentheses. Okay. Now, in those parentheses, in order to get a minus here, we have to have opposite signs. Because if I were to multiply these two parentheses together, this second term and this fourth term would have to multiply together to make this minus b squared. And the only way to get a minus there is to have opposite signs. Now, once we've done that, the rest is really easy work. What you need to do is you need to take the square root of a squared. That'll be your a value, which you'll put here and here. And then you take your square root of your b squared, and that'll get you a b value, which goes here and here. I find that most students are able to recognize the difference of squares pattern, but they struggle with remembering it amongst all of the other factoring patterns that we learn. So let's go ahead and let's do a couple of examples. So up here, we know it's a difference of squares, so I'm going to set up a set of parentheses with plus and a set of parentheses with minus. And then we need to figure out what our a and our b is. So my a value here is going to be the square root of x squared. Okay, that would just be x. My b value would now be the square root of 49. So the square root of 49 is 7. So now to fill in my parentheses, wherever there's an a, which is in the front of each parentheses, I'm going to write the letter x. And wherever there's a b, which is the back of each set of parentheses, I'm going to write the number 7. And there we go. That is the fully factored form for difference of squares. Now, sometimes you'll have a difference of squares that doesn't quite look like a difference of squares, such as this one here. Okay, 7 isn't on my magic number list, right? I mean, 7 falls here between 4 and 9. However, if you look a little closer, 7 and 63, 63 is a multiple of 7. So you could find a GCF between those, which in this case is 7. So what I'm going to do is I'm going to factor a 7 out from the set of parentheses. So here we go. So 7x squared divided by 7 is x squared, and 63 divided by 7 is 9. And there we go. So now we have an x squared and we have a 9, which are both perfect squares, and we can factor apart that parentheses. Now just a reminder here, when you do fully factor, this 7 that we factored out has to stay here. It has to be out in the front, or else you're gonna not have your full solution. Remember, in the end, we should be able to multiply everything back together to get to our original problem. And if we don't multiply the 7 back into our solution, it won't take us back to 7x squared minus 63. So here, the x squared minus 9, I'm going to set up two sets of parentheses, one with a plus, one with a minus. My a value, so the value being squared here, is x. My b value, 9, is 3 squared, so my b is 3. So in the fronts of my parentheses, I'm going to fill in an x, and in the back of my parentheses, I'm going to fill in a 3. And this is my final solution. Now let's try another one. Let's think this through. So we're looking for a number that goes both into 45 and 125. So because they both end in 5, I know that they are both divisible by 5. So I'm going to see if that's my GCF. So I'll take a 5 and factor it out from the parentheses. Oh, geez. Okay, so 45x squared divided by 5 is 9x squared. And 125 divided by 5 is 25. So then I look, are there any things that can go into both 9 and 25? No, there aren't. So that was, in fact, my GCF. And now if I look at it, now I have a difference of squares. Notice here there's a number in front of the x squared. That's okay, as long as that number is a perfect square. So if you look here on the left, you can see that 9 is on my perfect square list. So I'm going to go ahead and set up my GCF and my sets of parentheses. One with plus, one with minus. My A value, so the thing being squared to make 9x squared, is 3x. My B value here is 5. So in the front of my parentheses, I'm going to put 3x and 3x. And in the back of my parentheses, I'm going to put a 5 and a 5. Now, sometimes, depending on what values are being squared, you might encounter a problem like you see here with the 4th. Now 36 and 9, those are both on my my perfect squares list. So I can factor this. Okay, the square root of 36x squared is 6x, and the square root of 9 is 3. So I can factor this into 6x minus 3 and 6x plus 3. However, this isn't fully factored because there's still a GCF that I can take out. So 6 and 3, those are both divisible by 3. So that first parenthesis would turn into 3 times 2x plus 1, and the second set of parentheses would turn into 3 times 2x minus 1. And then we would need to collect those 3's together as my GCF. So the 3 and the 3 multiplied together makes 9. And then the rest of everything stays the same. So 2x plus 1, 2x minus 1. Now I could have saved myself the hassle if I had just looked at these numbers. 36 and 9 are both divisible by 9. So instead, I could have factored a 9 out as my GCF, and I would get 4x squared minus 1, which would take me a little more directly to this point right there. So you can think through this pattern. Now here's why the difference of squares is nice. Not only is factoring it easier, but going backwards is often a lot easier. So if I have two things that are called conjugates, okay, a conjugate is a term that has the same layout here. It's a binomial, and conjugates have the matching first and second terms, but the signs inside them are opposites. Okay, so all of these outcomes here are conjugates to each other. Now, if I have something that has a conjugate, when we go to multiply it together, I'm going to show it here with the box method. When we go to multiply it together, the middle term falls out. And so that's going to be a key thing for us later on in mathematics when we're dealing with imaginary and irrational numbers. So say, for example, I'm doing x plus 7 and x minus 7. If I multiply all the stuff on the inside, x times x gives me x squared. 7 times x is 7x. Negative 7 times x is negative 7x. And negative 7 times 7 is negative 49. Do you see how here on the diagonal these cancel out? Yeah, so that's kind of nice. We're going to need that later on in mathematics. So keep the idea of conjugates in your head. That's the end of my difference of squares video. My next video should be talking about one of my favorite patterns in factoring. Until next time.